Recording progress.
This video is for my sixth grade math class. This covers the lesson that we did on Monday, May 1st. So we have lesson 97 on page 175, introduces finding the perimeter of other polygons. So last week we learned about calculating the perimeter of triangles, squares, and rectangles and what those formulas were for those special polygons. This one is going to cover other shapes that we don't really have names for. They're just got multiple sides. So first though, we did a bell ringer to get a little bit of practice with calculating discount. So I want to, if you would, this is all review, so you should be able to pause the video and then try to calculate the amount of a discount as well as the sale price of an item. So I suggest you do that and give it a try and then start this back up so that you can see the walkthrough of how that work is done and then how we solve it. So we have an item whose regular price is $289 and it has been put on discount of 18%. So first we have to find the amount of discount. Excuse me. So remember, the discount is just the part that we're trying to calculate. So we're getting a dollar amount in this case. So your answer is going to be in the dollar amount. But this is really just when you think of amount of discount, then that's like 18%. Think of that as 18% of 289. So we follow our usual steps when we find the percent of a whole, and we convert our percent to decimal. So the understood decimal in any whole number is after the number in the ones place. And so to convert that into a decimal, we move it 2 places to the left. So we end up with 0.18. And then of means multiplication, so that's times 289. And then, of course, our answer will be in dollar amount. So then we just do the multiplication. So that's 289 times 0.18. We know that we have 2 digits behind a decimal place. So we'll add that at the end. Until then, ignore the decimal. Excuse me. So go ahead and do your multiplication. 8 times 9 is 72. So carry your 7. 8 times 8 is 64. Plus 7 is 71. So we carry our 7, and 8 times 2 is 16. Plus 7 is 23. And then 1 times 289 is just 289. So 289. And you can annex in your 0 for that if you need to. But make sure that 9 goes under the 1 in your second vector. And then you just add. So 2, that's 10. So carry my 1. 11 plus 1 is 12. Carry my 1 and 5. So the discount that's taken off of the regular price is $52.02. Now, in order to calculate the sale price, remember that's simply the total. So the sale price is the total or the original price. We'll use that, original, minus the discount amount. So this is 289, and I'm going to add 2 decimal places, minus $52.02. Again, the price actually paid. And then we just do the math. We have to borrow, so that becomes a 10, which makes that a 9, but we've got to borrow because it's a 0. We can't go from 0 to 9. So 10 minus 2 is 8. We bring down our 9. 8 minus 2 is 6. And then 8 minus 5 is 3 and 2. So the price paid is $236.98. Okay, so hopefully you were able to figure that out. If not, make sure you get some practice on those. We'll continue to see those on assessments. Okay, so this is a little bit of a review of geometry. This is sort of the parts of polygons, and we're going to talk about angles. All right, so this first one, where you have a beginning, but it goes on into infinity, is a ray. And again, hopefully you can look at these and know what they are. So practice that. This is a line because it goes to infinity in both directions. It never ends. So this is a line. And then when you have a line, but it has the two dots, 2 points on each end, that means that it stops. So this is a line segment. It has a beginning and an end. All right, and what do we call two lines that will never intersect? But these are parallel lines. And now going back over to the top on the right side, just a dot. Point is, this is called a point. It's just a one coordinate in space on the plane. It's a point. So this one is, so I'm not really addressing the angle necessarily, but the two rays that intersect here create, so these are, if they go on forever, oops, I can't draw, there we go, that create a 90-degree angle are called perpendicular. Perpendicular lines. Now there's two parts to this one. So what do we call that measurement, that inside space between two rays? That is an angle. Specifically, this one is less than 90 degrees, so it's called an acute angle. If it is exactly 90 degrees, we call that a right angle. And then the point where those two rays meet or intersect, any point where two lines intersect is called the vertex of those lines. So this last one here, we're talking about what do we call these two lines. They're not creating right angles, so they're not specifically perpendicular because they don't have that square that denotes a right angle. These are just intersecting lines. And again, lines always intersect at a vertex. Any point there is called a vertex. Okay, so let's move on into the new content on page 175. We're talking about the perimeter of other polygons. So if you remember, perimeter is simply talking about the distance around a shape. So in this case, this is the example that you've got at the top of page 175. We've got this polygon with multiple sides, and we know 4 of the 6 sides that exist on this. We have an unknown right here, and then we also need to know what is the length of this distance, this line segment down at the bottom that makes up the bottom portion of the polygon. We have to calculate that in order to know the entire perimeter of this polygon. Now, from the information we're given, we're given enough information that we can find the length of the sides that we're not given. So what we want to do here is, and it's important to note that these are perpendicular angles. So that means that those sides go straight up and down. So if this side right here is 18 feet, then that, and this side, this little bit right here is 15 feet. We know that this difference right here is the difference between 18 and 15. So we can calculate this little unknown section up here by taking the whole side on 18 feet, subtract what we know, the 15 feet, and we find that that gives us 3 feet. That's the remaining distance on that right side, and so this is 3 feet in height. Now, on the bottom, again, because these are perpendicular lines, we know that that entire bottom length is this section here plus this little section here, because that whole distance is going to be equal to the bottom of this polygon. So we can calculate that by having 18 plus 18. We add those together and we get 16, carry my 1, 36 feet. So this bottom length of the polygon is 36 feet. So now that I've been able to calculate the sides that I don't know, one, by subtracting. So I take the whole, 18 feet is the whole length from top to bottom, and I subtract what I'm given, the 15 feet. That gives me the remainder, the 3 feet that I don't know. And then on the top and bottom, I know that the bottom is the sum of that uppermost top section of 18 feet and then the midway section of 18 feet. I can add them together. So again, you use your critical thinking skills to look at it to determine whether you need to add or subtract. So once you do that, you've got all of the different parts. I'm going to clean this up a little bit. You've got all the different sides of your polygon. And so the perimeter is simply the addition of each line segment that covers the different sides of this diagram, this polygon. So we now just do the math. And when I do this, especially when I have multiple sides like this, I sort of mark them somehow. So I like to use check marks. So I'm going to use 18 feet here. And then I'm going to add another 18 feet. That way I don't miss one or count one twice. I know that little section is 3 feet. This one here is 18 feet. I've got 15 feet here. And then I've got 36 feet here. And we add that together. So 8 plus 8 is 16, plus 3 is 19, plus 8 is 27, plus 5 it gives me 32, plus another 6 is 38. Carrying that 3, 3, 4, 5, 6, 7, plus 3 is 10. So that means that the entire perimeter of this polygon is 108 feet. Now you can see what I've done in the example that you've got on page 175 as well. And they talk about the fact that the unmarked distances of 3 feet and 36 feet are found using the distances that they gave us. And I've shown you how I did that. All right, so you're going to use that information to then find the perimeters of the practice that we've given you in section 1. And then in section 2, we've got a little bit of review. You're going to use formulas to find the perimeters of both rectangles and then in number 3 of squares. So I'll go over, give those to you in just a minute before you try to do that work on your own. I'm going to do 1A together because this one was a little bit confusing to your classmates. So again, I've sort of poorly recreated what you've got in your book. Your book is a little bit more proportional. Mine is just sort of a somewhat similar example, but I've labeled everything exactly how they have in the book. So you can see here, there's a couple of sides that they did not give us. They did not give us this interior left side right here, and they did not give us the exterior left side either. But again, because these are right angles, then you know that this sort of creates, I'm going to sort of recreate it down. You don't have that inside part, but at least for the outside, you sort of have this rectangular shape. Because if you remember, a rectangle by definition means that all the interior angles are right angles, they're 90 degrees, which means that your length and your width, those are the same value. They're both the same length or same distance. So when you go to figure these out, you know that this left side is exactly the same. It's congruent to the line segment on the right. So if that's 10 feet, and these are all right angles, this is also 10 feet. The interior, you have, they don't give, do they give it to you? They don't give it to you, but because we're going to assume that these are also sort of exterior right angles, which means that that interior left side is going to be exactly the same length as the interior right side. So these also match. This one's going to be 7 feet. Excuse me, as well. So now that you've got that, again, let me clean this up a little bit. You can now add up all of the different sides and get your total perimeter. So I'm gonna start with the left and then kind of go clockwise around it. So that looks like loft. I don't know why I can't unsee the word the word loft there. Okay. Okay, so we have the 10 feet right here, and then I'm going to do 12, and then 10 again, and then I've got this guy right here, 3 feet. Now I'm going inside, so I'm going to get that 7, and then add that 6, and then the other 7, and then the 3. You just add them together. So 2, 5, 12, 18, 25, 28. Carry my 2, 2, 3, 4, 5. And so now we know that the perimeter of this polygon is 58. Don't ever forget your units, feet. We've got to keep our units in our answer. So it's not just 58, it's 58 feet. Same thing up here. All right, so try that again for B and C and D. E is a little bit confusing, but just do your best. You can see that there's 1, 2, 3, 4 sides that you don't have in E on number 1, but they've given you information that you can use to find it. So challenge yourself, give it a try. Don't worry about F. We're not going to worry about the greens. Okay, and I want to look at number 2 and number 3. So these are reviews. So if you have any questions or need some help, go back and look at the work you did for lesson 96 and 95. That covers your perimeter of a rectangle and perimeter of a square. So for number 2, I'll give you the formula though. Whenever you find the perimeter of a rectangle, it's always, and I put the little lowercase subscript r, so I know this is the perimeter of a rectangle. Perimeter of a rectangle is 2 times the length plus the width. So again, if you've got a rectangle, they tell you that it's a rectangle, and you know that it is, let's say, 8 inches by 12 inches, then this is your length, or length or width, pick your one. That's length, that's width. So you just plug that into those variables, and we have 2 times 8 plus 12. An order of operation tells us that we solve inside the parentheses first. So this just becomes 8 plus 12 is 20, so 2 times 20, which means that our perimeter is 40 inches. And that's all you're doing for number 2. You can draw the diagram if you need to, but when they're telling you this is like 8 inches by 12 inches, you can draw it like I have here, and that'll give you a better idea. But you just plug in, 1 is the length, 1 is the width, add them together, multiply them times 2, and you've got your perimeter. So try that for 2. And then squares, I think, are even easier. So the definition of a square is that all of the sides are the exact same length. So if you know 1, let's say it's 4 inches, you know all of them. So the formula for the perimeter of a square is just 4 times S, which is that length, that side. So in the case of our example here, I've got 4 inches. We know it's a square. So the perimeter is just 4 times 4, which means the perimeter of this square is 16 inches. So that's what you're doing for number 3. Don't worry about the problem solving strategies on page 176. And I will make this, actually, I'm going to go ahead and keep this together. So this is the lesson that we did in Monday, and we worked through the rest of those. It was a little bit confusing for everybody, so we had to spend a lot of time on it. And so that's all that we got through on Monday. So this one starts the lesson for Tuesday. Just use a different color. So this one, again, still math 6, but this is lesson 98. that starts. This one is covered on page 177 and 178. All right, and this one was a little bit complicated, but if you just remember, when you have multiple units in a polygon, convert them to either one unit or the other. Let me show you what I'm talking about. So if we have a, let's see what we have here. If I have a rectangle, get something drawn here. I'm gonna pause it, get this figured out real quick.
Recording in progress.
Here we go. So I've got my example, I've got it labeled. So I've got a rectangle and its length is 15 feet. Well, its width is 15 feet and its length is 8 feet 3 inches. And I need to calculate the perimeter of this. So the first thing that we need to do, step one, is we need to convert that length to only feet. So for step one, we have 8 feet 3 inches. And you can draw this. We've done this in the past and it kind of looked like this. So 8 feet 3 inches is how many feet? Well, we know it's 8 feet. We just don't know what the rest is. So you're going to convert the inches to a fraction. And sometimes you're going to end up with one of those repeating decimal fractions, like 1/3, or 1/3, 2/3, something over 9. So you want to keep it in fraction so that you don't have to round a repeating decimal. So what we need to do really is we need to convert 3 inches to some sort of feet, some amount of feet. Now we know we're going from a smaller unit to a larger unit. And so we need to divide. And then what's our conversion? Well, there's 12 inches in 1 foot, so we're dividing by 12. So when we do our math there, we take our part, which is 3 inches, and we divide it by our whole, which is 12. So 3 inches equals 3/12 of a foot. But we can reduce this. So if I reduce this, I can divide the 3 and the 12 by 3, and I get 1/4. So 3 inches equals 1/4 of a foot. So I add that to my 8, and so I know that 8 feet 3 inches is 8 1/4 feet. So now I have that as my length, I think is what I've been calling it. So this is 8 1/4 feet. So you see how now that in that distance, 8 1/4, 8 feet 3 inches, is now only in feet. So now we can calculate the perimeter using the 15 and the 8 1/4 to go ahead and solve it. All right, so the second part is now we just use the write the formula for, get this down, for the perimeter of a rectangle. So we know that the perimeter, step 2, perimeter of a rectangle is equal to 2 times the length plus the width. Well, I know my length, that's 15 feet, and my width is 8 1/4 feet. So again, order of operation tells us that we need to add what's inside of our parentheses first. And I'm going to do that as well because one is a whole number and one is a mixed number, and those are a lot easier to add together than they are to multiply individually, because then I'd have to convert it to an improper fraction. I don't want to do that, not yet. So the third step is that we then solve. Right, we've plugged in our values, so now we can solve it. All right, so for step 3, my first thing is I have 15 plus 8 1/4. Well, I don't need to turn anything into a fraction for that 15, because what's 0 plus 1/4? Because I'm adding, I just bring down the 1/4. I don't have to worry about anything else. Then I just add the 15 and the 8. So 5 plus 8 is 13, carry my 1, and it's 23. So that means that inside my parentheses is now 23 1/4. So I'm going to plug that back in here. let's see, so perimeter of a rectangle equals 2 times 23 and 1/4. All right, so now I am multiplying a whole number of times a mixed number. And whenever we multiply with fractions, we've got to convert them to improper fractions. So this one's pretty easy. I know this is 2/1. I've got to figure out the 4 times 23. So when we do that, we have 23 times 4. 4 times 3 is 12. Carry my 1. So 92. And then plus 1, because we got to add that numerator, makes it 93. So that's 2/1 times 93/4. I know these are pretty big numbers. Don't let them intimidate you. You got this. All right, I'm going to change colors so it's a little easier to see. So now we cancel. The smaller the numbers, the better. So that becomes a 1, and this becomes a 2. So now I have, well, let me go back to purple. Now I know 1 times 93 is 93, and 1 times 2 is 2. So now I just have to convert my mixed number, or my improper fraction, excuse me, back into a mixed number. So last step, sorry this is getting a little messy, but I know y'all like to just do long division. So 2 times 9, 2 goes into 9, excuse me, 4 times. So that makes 8. Bring down my 3, and 2 goes into 13. We're going to need a 0 here. 2 goes into 13 6 times, and so we have 12. And then bring down that 10. So 2 goes, okay, so technically I could probably leave it at, I could leave it a fraction. Either way, you leave it a fraction and you get 1/2, or you convert it to a decimal and you get 0.5. Same thing, but no remainder. So that means that the perimeter of this rectangle is 46.5 feet. Now, let me show you the other way that you can do this. Similar process, but instead of, well, actually, no, in this case, we definitely want to convert it to feet. We want to convert it to feet because this is in feet. We'll get to some more example, a different example of where you can convert it to the greater unit or the lesser unit. So let's look at the example. Let's see. Do I want to use that one? Sorry, give me just a second. You know what? We're going to leave that like it is. I'm going to use example 1, or excuse me, yeah, example A from number 2 to show you how we might sometimes convert it to the lesser unit. First, I'm going to do A for number 1, so you can do that with me. And then you can do B on your own to give that a try. And then for 2, I'm going to do A and you can do B on your own. And then I'll give you the kind of the rest of your work along with it. So let's go ahead and get into the class practice. So for 1A, we have 6 feet 6 inches by 7 feet. Now, if you're doing this on a separate sheet of paper, which I might suggest, they give you room, but only if you write small. I like to have a visual aid when I do this. So I know that 6 feet and 6 inches and 7 feet are kind of close together, but this is still a rectangle. It's still slightly longer than it is wide. So I'm going to make this my 7 feet, and this is going to be my 6 feet 6 inches. So for number 1, they've asked you to convert to the greater unit before you find the perimeter. Well, the greater unit is feet. Those are obviously larger than, longer than inches are. So our first step is we need to convert the 6 feet 6 inches into just feet. So I know the 6 feet is going to stay the same. So the thing I really need to look at here, excuse me, is 6 inches equals how many feet? So I'm going to inches to feet, which means I've got to divide. I'm going from a smaller unit to a larger. And then my conversion rate is 12 because there's 12 inches in 1 foot. And so I need to now do my work. So 1 foot is 12 inches. So that means this is 1 divided by 12. Excuse me, 6 inches. Sorry, the part that I was given. So 6 inches divided by 12. And then it just reduces. 6 goes into both of these, and we end up with 1/2. Now, it's very likely that you looked at it and you know 6 inches, oh, that's half of a foot because a foot's 12. But I'm just doing the math so you can see how it works. Not all of them are quite this obvious. So now, now we can plug that into our two values and solve. So the perimeter of a rectangle, again, is 2 times the length plus the width. My length is 7 feet. Width is 6.5 feet. So let's plug that in. This is 2 times 7 plus 6.5. All right, I'm going to come on over here so I know that I have to solve the 7 plus the 6.5 first. So 7 plus 6.5. That half I just bring right on down, and 7 plus 6 is 13. So this is 2 times 13.1/2. Well, that's okay. I'm just going to do it the long way. Okay, so let's do that part. So that's 2 over 1 times, and I'm going to go ahead and turn the 13.1/2 into an improper fraction. So 2 times 13 is 26, plus 1 is 27 over 2. Well, this will be a nice whole number. So my 2's cancel. So these just become 1. And so this becomes 27. Therefore, the perimeter of my rectangle is 27 feet. And that's it. You're done. So our first step is we solved inside of the parentheses. My second step is that we then multiplied that answer, that sum, times 2. And got our final answer. All right, so you try 1B. Let me go ahead and go do 2A. All right, so for 2A, this one is asking us to convert to a lesser unit before we find the perimeter. So for A, they've told us that the length of this rectangle is 7 feet, 6 inches. So we know that's 7.5 feet. We don't know how many inches that is. The width is 4 feet, 4 inches. All right, so if we're converting these to the lesser unit, that means that we are converting them to some amount of inches. Put that over here. I'll write it out. It looks weird by itself for some reason. Okay, so let's do the length first. I know that the 6 inches, it's already there, so I'll just add that on at the end. But for 7 feet, 6 inches, our first step is we need to convert 7 feet, whoops, getting ahead of myself here, equals how many inches? Well, we're going from feet to inches now, so we're going to multiply. We know that there's 12 inches in 1 foot. So for our math, we have 7 times 12, which is 84. But now we have the second step. We have to add that additional 6 inches. So this is 84 inches, but we've got to add the 6 inches to that 7 feet, that 84, to get our total inches. So that's 10, carry my 1 is 9. So I know that 7 feet, 6 inches, I'm going to put this different color so I don't lose it, is 90 inches. All right, let's do the other one, the width now. So that was the length. So the width of 4 feet, 4 inches. So my first step, I got to convert those 4 feet to some unknown amount of inches. As always, we multiply. We're going to multiply times 12 because that's our conversion rate. So 4 times 12 is 48. So 48 inches. And then step 2, we add that last 4 inches. And we get 8 plus 4 is 12, carry my 1, 52 inches. 52. So now we have figured out that these are 90 inches and 52 inches. So now we've got them all in the smaller unit. We can then calculate the perimeter. Make that a little lighter. So perimeter of a rectangle is, we should all know this by now, 2 times the length plus the width. We're doing it in inches now. So this is 2 times either one. Length is 90 plus the width, which is 52. So our first step is we do 90 plus 52. The order of operation is inside the parentheses. Bring down your 2. 9 plus 5 is 14. So this is 2 times 142. Second step is we do the multiplication. So 142 times 2 gives me 482. So my final perimeter of this rectangle is 284 inches. There we go. And there's your answer. So give that a try with B. With B, you're converting, obviously you have meters is the length, centimeters is the width, centimeters is the smaller unit. So you're going to convert that 9 meters into centimeters. All right, I want you to do number 3. Those are the perimeter. So that's a review of what we just did, where you have a square and then you have this random shaped polygon. So you've got to calculate the sides you don't know, and you can figure those out from what they gave you. Also, just remember let's go back to formulas. So we've talked about the formulas. Where are they? Let me see if I can find them. Did I? Here we go. Well, they're sort of here. Let me just put them all together. Let's do this. Formulas. So the perimeter of a rectangle is 2 times the length plus the width. That does not look like an R. Here we go. The perimeter of a square is 4S. So it's 4 times whatever the side is. So 4 times S. And then the perimeter of a triangle. So if you have a triangle, we usually call these sides A, B, and C. So if you have a perimeter of a triangle, we'll do a right triangle. They're just much nicer. All right. Then you have A, B, and C. So that means the perimeter of that triangle is the length of A plus the length of side B plus the length of side C. So I think that's a green, so you probably won't have to do that problem, but I want just so you have all of your formulas for perimeter in one place. You can jot those down in your notes. All right, so what you're completing here is number 1, you only have 1B, so I'll say 1B, 2B, or not 2B, sorry, I couldn't help myself. 3A and B, because C is green. Try 4A. Shouldn't be too difficult. And then I need you to do the review. This is what I asked my class to do for homework, is I asked them to do numbers 5 and 6 on page 178. These are all review. You're writing equivalent decimals from percentages and fractions, and then you're doing a little bit more practice of finding percentages. All right, so get that done, and that will get you caught up through Tuesday. Today, we actually spent the majority of the time practicing and memorizing those geometric shapes. So what I would like for you to do, and this would be your Wednesday lesson. So this is Wednesday. There's no actual lesson. Hold on. So tired, I can't write and talk anymore, is I want you to make note cards of the geometric shapes. So These are on page 169. So the simple closed figure, what are similar figures? What are congruent figures? Polygons, and then the different types of polygons. Um, the rhombus is like a squared parallelogram. Trapezoid, the pentagon, the hexagon, the heptagon, and the octagon. All right, so this will cover you through Wednesday. We're actually gonna even do more of that on Thursday. So you're kind of fine if you want to kind of work on this through Thursday until you're able to get back into class. But really study those geometric shapes. They're gonna be on the test. You're not gonna be able to like look at the book because I need you to be able to understand the parts of each types of these so that you can recognize them when you see them. So make note cards, get some index cards if you want, and draw the shape on one side and the name of it on the other side so you can practice with those. Other than that, that gets you caught up. So if we do anything extra tomorrow that I haven't covered in this video, I'll make another video tomorrow and send it to you. All right. Thank you so much.